Okay, the EKG, we're going to look at rate. This goes along with Chapter 4 of Dubin's Rapid Interpretation of EKG. So the systematic approach to an EKG is to look at the rate-rhythm axis, look for hypertrophy, and look for infarction. So in this video, I'm talking about the rate. So as you remember, each big box has 5 small boxes in it. The big box is 200 milliseconds or 0.2 seconds. The small box is 40 milliseconds. And it's approximately 1 millimeter wide. So if I do dimensional analysis, I remember that there's 1,000 milliseconds in a second and that there are 60 seconds in a minute. So I have 6,000 milliseconds per minute, and I multiply that by, so I know that I have one big box for every 200 milliseconds. So what I can figure out from that is that I have 300 boxes, 300 big boxes per minute. So if I take that 300 boxes per minute and I multiply that by one beat over the number of big boxes, which got cut off, and this is the number of big boxes in an RR interval. So I'm saying I have my wave, and you'll remember that the RR interval is the distance between two R waves, or really it can be defined, it's defined as the distance between two R waves, but you could really pick the distance between any two similar waves, so two P waves or two T waves, but we like to use the two R waves, mostly because they're really distinct and easy to find. So anyhow, if I multiply this out, number of big boxes cancels out, and what I end up getting is, so remember I said I had one beat between a certain number of big boxes. So when I multiply this out, of course, the number of big boxes cancel, and what I end up with is beats over minutes. And so what you end up with is that the heart rate in beats per minute is equal to 300 divided by the number of big boxes in an RR interval. Now, Dubin likes to encourage people to memorize the 300, 150, 100, 75, 60, 50 method. And he teaches you to memorize it as two different groups of 3. So you memorize that, and then go on. If you're observant, you'll realize that he's just doing the factors of 300. So 300 divided by 1, 300 divided by 2, 300 divided by 3, and so on. If you really want to be awesome, I say memorize the factors of 1500, because you'll remember there are 1500 small lines for every 300 big lines. And so I demonstrate. We got 1500, 750, 500, 375. Of course, I got 300 up here, 250, 214, 188, and 167. So you're going to get more accuracy by doing it this way. But of course up here, of course, you got the 300, 150, 100, 75, 60, 50. So in between 6 big boxes, you can basically memorize this and know what the heart rate is, or you can divide by 300 by the number of big boxes. So if we started here, there's 1 big box, 2 big box, 3 big box. 300 divided by 3 is 100. There is an easier way. So if you look, if we zoom in really close, it's hard to see, but if you look on here, there's a tiny little tick mark right there, and there's another tiny little tick mark right here, and what this typically is a 3-second mark. And so if we're really quick at math, we know that 2 3-second marks is equal to 6 seconds, and if I take 6 seconds and times it by 10, then I get 60 seconds. So if I take the number of beats in here and I times it by 10, I get the number of beats in a minute. Now really first, let's go in and look at this and do the previous rule. So let's say we've got 1, 2, 3, 4. We've got 4 big boxes in here. You can do 300 divided by 4, which would be 75, or you could say there's 300, 150, 100, 75. But you'll notice there's a little bit of gap before that, and there's a tiny little gap before that, and so we're actually just a little bit slower than 75. And let's see if this 6-second strip can help us to identify that. We count, we start here, we go, there's 1, 2, 3, 4, 5, 6, 7. There are 7 marks in this, so we multiply it by 10 and we get 70 beats per minute. Now, one thing I'll say about this is the EKG papers that they've been giving us for PBL do not seem to have these 3-second marks on them, or at least I haven't noticed them, and so it's probably just good to know the 300 rule. Divide everything into 300 and get your answer. However, there is one more trick, and that's because a typical, your normal EKG, you've got lead 1, 2, lead 3, then you've got your AVR, AVL, AVF, then you get V1, V4, V2, V5, and V3, V6. And then down at the bottom, usually you got like lead 2 that goes all the way across. And during this transition, this whole transition is 10 seconds. And so while the math isn't quite as easy as doing a 6-second strip and multiplying by 10, you can do the whole 10 seconds and multiply by 6. And the advantage is you get slightly more accuracy as well. So the longer the seconds, the more accuracy you get. If you did 60 seconds, you'd be perfectly accurate, right? The last thing Dubin, or actually the very first thing in Chapter 4 that Dubin liked to hit on were the automaticity foci. And basically the point of it being that you have automaticity foci that are keeping the rate of the heart. That's what causes the heart rate. And so the main one is the SA node. The SA node is the fastest one. It's going to hit you with about 80 beats per minute. And then there are other atrial automaticity foci that are close to the range of 80, so they're between 60 and 80. And then you have, of course, the SA node and these junctional automaticity foci, so the SA node being close to 60 and the other junctional automaticity foci in that junctional area being between 40 to 60. And then, of course, you also have foci in the ventricles that will put you between 20 and 40 beats per minute. So like I've done down here, if you just put 20, 40, 60, 80, and then here you put ventricle, junction, and atria, then you'll have your automaticity foci and how fast they pace. And so what happens basically, if the SA node gets knocked out, then you have you can pace around between 40 and 60 beats per minute. If the AV node gets knocked out and all these junctionals get knocked out, then your heart can pace between 20 and 40 beats per minute. And so you really, in order to get down to 20 beats per minute, there has to be a lot of stuff go wrong. And the way this all works is through a mechanism called overdrive suppression. So what I've written here is that when one foci goes off, the others get reset. If the atria is beating at 80 beats per minute, it's going to go off, and as soon as it does, it's going to cut all these off and reset everything. And so this one, the junctional nodes, the junctional foci cannot go off unless these atrial nodes either slow down supremely or stop working. And so overdrive suppression keeps everything else from going off instead of the SA node.